This video is brought to you by Squarespace, the all-in-one website platform. More on Squarespace later in the video. Welcome back to Geographics. I'm your host, Eric Malachite, author of Echoes of Olympus Mons, which just so happens to be pretty related to today's topic. Yes, we're talking about the largest volcano in the solar system, how it's thought to have been formed, and so much more. The script for today's video was Larry Holsworth, and don't worry, my ScienceGet alumni all have a few comments scattered throughout the video. Wink. Be sure to follow the links in the description, and let's go ahead and dive head into one of my favorite research subjects. Mars. The fabled red planet has long played a mythological role in the minds of humanity. Since the late 19th century, humanity has observed its orbit and pondered over the existence of its landscape. Its terrain is rugged, rock-strewn, and barren. Its sunrises are blue, and its skies range from pinkish red to butterscotch. Its temperature ranges from an almost temperate 20 degrees Celsius to a frigid negative 150 degrees, or 70 degrees Fahrenheit to negative 225 degrees. From a distance, it appears to feature canals, indicating the existence of large bodies of water, though it is now known to be an arid environment. The existence of Martians, little green men, or in my case, dark matter phantoms, has long been a favorite of writers of science fiction and horror. Fictional Martians have over time invaded the Earth to conquer humanity in novels, short stories, motion pictures, television, and radio productions, and in folklore. They have also been considered from a humorous bent, such as the stranded on Earth Martian portrayed by Ray Walston in the 1960s situational comedy My Favorite Martian. And of course, Santa Claus battled the Martians in the 1964 camp film Santa Claus Conquers the Martian, which has a hilarious MST3K rendition. However, my favorite science fiction comedy involving Mars is none other than Mars Attacks, because, yeah, it speaks for itself, right? Mars has two moons, Phobos and Deimos. Phobos, of course, will be getting a video very soon, as long as you're all very good boys and girls for Santa Claus. The two moons orbiting Mars were featured in fiction more than a century and a half before they were discovered by astronomers, when Jonathan Swift described them in his satirical travelogue Gulliver's Travels in 1726. Swift credited their discovery to the advanced astronomers of Laputa. In 1877, their existence was confirmed by an Earth-bound astronomer, Asaph Hall, then working for the U.S. Naval Observatory. Curiously, the most accurate description of Mars was among the earliest in fiction. In 1656, a Jesuit polymath named Athanasius Kircher published a fictional tour of the planets, escorted by Cosmiel, an angel. They discovered Mars as being a volcanic wasteland devoid of life, with an environment hostile to humans. That view was more or less confirmed when probes from the United States and the Soviet Union arrived at Mars in the late 20th century, more than 300 years after Kircher's angelic visit. Thanks to the inhabitants of Earth, Mars is the only planet in the solar system inhabited entirely by robots. That is, robots manufactured by Earthlings. These tools of humanity have only been on the planet a relatively short time, yet they have contributed a great deal toward human knowledge of one of its closest celestial neighbors. Humanity's modern tools have confirmed what some speculated several centuries ago. The Martian environment is hostile to humans. The Martian planet is volatile, with evidence of powerful volcanic activity. As more knowledge of Mars is gained, more questions are asked, and new theories, often conflicting, emerge to explain how Martian features were formed, how the planet reached its current state of existence, and what the future may hold. In 1972, scientists confirmed volcanic activity on Mars played a considerable role in shaping the planet, and debate continues over whether that activity is extinct, dormant, or ongoing. Another fact has been confirmed beyond debate. The largest known mountains in the solar system are found on Mars, volcanoes so huge they defy comprehension in human terms. The largest of them all is known as Olympus Mons. Because of its arid environment and high winds, Mars is frequently beset with dust storms, which can, and often have, obscured the entire planet's surface from telescopic observations from Earth. When NASA's Mariner 9 orbiter arrived in Martian orbit in 1971, the planet was undergoing a global dust storm. As the storms abated and the dust began to settle back toward the surface of the planet, some of the earliest features to appear were the tops of mountains in the Tharsis Plateau, a range near the Martian equator. Located in the Martian Western Hemisphere, the Tharsis Plateau is the site of the tallest volcanoes known to exist in the solar system. 3 of these volcanoes are collectively known as Olympus Mons. They stand in a nearly perfectly straight line, as if they had been placed deliberately in relation to each other, equidistant guardians of a 4th monster volcano. The image of guardians, though fanciful, is further enhanced by the volcano's appearance. From above, they resemble the circular shields once carried by ancient soldiers. To the northwest, in Martian terms of the Olympus Mons, sits the largest volcano and the tallest planetary mountain known by humanity to exist. It is known as Olympus Mons. In sheer height, it has only one known potential rival, at least as of 2024. That rival, however, is not located on a planet, but rather on the asteroid Vesta. Asteroid Vesta does orbit the Sun, between the Sun and Jupiter in the asteroid belt, taking roughly 3.6 Earth years to complete a circuit. It also does draw other smaller asteroids into orbits around it temporarily, if one agrees that 2 to 3 million years can be referred to as temporary. After all, in cosmic terms, that's just a drop in the bucket. Orbiting the Sun and having its own natural satellites would seem to the layman to qualify as a planet, but it is not. Since it is not considered a planet, its peak found at the center of the crater of Ray Silvia, which reaches a height of 22.5 kilometers or 14 miles, does not gain consideration as a planetary mountain. Oh, the technicalities, right? Olympus Mons stands roughly 21 kilometers, 13 miles in height, though some means of measuring it assign it 16 miles in height. Roughly speaking, it is more than 3 times the height of Mount Everest, the tallest mountain on Earth. Have you ever wanted to build your own website but can never find the time to learn to code or deal with one of those messy content management systems? Well, Squarespace might be just what you're looking for. Squarespace is the all-in-one website platform, perfect for entrepreneurs, whether you're an artist looking to sell pop art renditions of Nicolas Cage, an author looking to get your library and name out there, or a disgruntled FBI agent looking to prove his sister really was abducted by Martians. Squarespace has all the tools you need to get the job done, all in one place and on your terms. With Squarespace's next-gen website engine, the Fluid Engine, you'll be able to choose from a template and customize it to your heart's content. And best of all, your website will be fully functional on desktop and mobile from the get-go. Need SEO and AI tools? With Squarespace's guided design system, Squarespace Blueprint, your website will be fully tailored to your brand or business, and you'll be able to make sure your website hits all those SEO sweet spots, ensuring you reach the right people to grow your audience the way you want. You can also make the checkout process super simple for your customers with flexible payments. Accept credit cards, PayPal, Apple Pay, and in eligible countries, offer your customers the option to buy now and pay later with Afterpay and ClearPay. Are you an educational content creator or a skilled professional looking to teach a new generation your unique skill set? Squarespace also offers the tools you need to design and sell online courses. Start with a layout that fits your brand, upload your videos, and customize everything using Squarespace's next generation editing technology. And in addition to that, Squarespace also offers a way to organize your video library and showcase your content with video pages. Ready to get started? Check out squarespace.com for a free trial. And when you're ready to launch, go to squarespace.com/geographics and use promo code Geographics to save 10% off your first purchase of a website or domain. A shield volcano is so named because when viewed from above with obstructions removed, it resembles the circular shields carried by soldiers of antiquity, lying flat on the ground. These volcanoes are formed by repeated eruptions of lava from within. They are found all over the Earth. The Hawaiian Islands are shield volcanoes. There are shield volcanoes in the Galapagos Islands, in Alaska, Iceland, and in East Africa, as well as in the world's oceans. Oregon and California contain several examples of this type. Shield volcanoes are thus readily accessible for study, and lessons learned from Earth-mount examples are applied to those found elsewhere in the solar system, including Olympus Mons. As many of you who have taken a basic science class know, magma is molten or semi-molten material beneath the surface of a planet. A volcano erupts when the pressures within the magma chamber beneath the surface reach a point that the chamber can no longer contain the magma within, and it is forced to the surface. It then flows down the side of the volcano as lava, and as it cools, becomes rock. Eruptions can be explosive or not, depending on the conditions within the volcano. A volcano that is not in a state of eruption can nonetheless be active, meaning the magma contained beneath is continuing to build pressure and will at some point be released by erupting. Many of the earthly shield volcanoes remain active, including in Hawaii. Those on Mars appear to be inactive. Scientists generally regard Olympus Mons and the Tharsis Montes standing guard nearby to be inactive, with the last eruption occurring on Mars 25 million years ago, more or less. However, in a science where the period of 2 to 3 million years may be considered temporary, there must be some latitude given to the concept of what may be considered inactive. It may be just excruciatingly slow in human terms. All of that is an extremely convoluted way of saying that the next eruption could take place when we're all extinct. How's that for some existential dread? One must ponder why on Earth shield volcanoes do not reach the lofty heights of their extraterrestrial brethren in the solar system. The answer partly lies in the construction of the Earth in comparison to Mars. The red planet does not possess the shifting tectonic plates that lie beneath the Earth's surface, at least not to the extent as does Earth. There is one theory being explored right now, which is really fascinating. It suggests that early in Mars's evolution, it underwent a process similar to plate tectonics. Technically a precursor to it, though. This process shattered and broke the crust up, causing it to subduct in some areas, but the effects of this would have been temporary and did not lead to plate tectonics like we see on Earth. Tectonic plates also contribute to the creation of volcanic chains, such as the Hawaiian Islands. On both Earth and Mars, magma is collected in what volcanologists call hotspots. These hotspots beneath the surface do not move. On Earth, tectonic plates shift, often covering a route formerly followed by magma to the surface, forcing the magma to find a more convenient path to the surface. Once the magma has accomplished that formidable task, a new mountain is formed. On Mars, the absence of shifting tectonic plates allows the magma to follow the same convenient path over and over again, steadily building the same mountain continuously. However, more recent studies suggest tectonic plates may have contributed to Martian development through shifting relatively recently. The Martian shield volcanoes grew over long periods of time, uninterrupted by other seismic events, allowing them to grow both in height and in ever-increasing footprints. With each eruption, Olympus Mons grew. How many eruptions occurred, or whether the mountain was just built by a few eruptions which resulted in steady flows over millions of years, is unknown. The result is that Olympus Mons is enormous beyond earthly comprehension. The diameter of the mountain is more than 20 times its height. If one were to place it on Earth, its footprint would cover the US state of Arizona. In Europe, it would cover most of France, or the entire range of the Alps. The enormous size of its base and the sides of the mountain, which slope gently from top to bottom, as it were, creates a somewhat intriguing fact. If one were to stand on the peak of this mountain and gaze toward the Martian horizon in the distance, one would experience little, if any, perception of height. Instead, it would appear to be as if one was standing on a gentle rise, despite being over 13 miles above the beginning of the slopes leading to the peak. The huge size of Olympus Mons, as well as the nearly as imposing dimensions of the volcanoes comprising the Tharsis Montes, has led to a theory regarding the lack of surface water in Mars. The four mountains are all part of the same volcanic plateau, and likely formed at the same time, though that time is measured in millions of years. According to the theory, the shifting of so much mass in the form of magma from deep within the planet to its surface changed its balance. The weight added to the outer areas of the rotating body caused it to shift its axis of rotation. Essentially, Mars tipped to its side due to the shift of balance. Tipping over caused the outer crust of the planet to shift towards the equator and away from the poles, perhaps as much as 20 degrees. Both the direction of rivers and the climate of the planet were affected. What would have equated to the temperate regions, at least in Martian terms, grew hotter, as did the polar regions. This theory posits that Mars tilted on its axis roughly some 3 billion years ago. That corresponds to a time on Earth, according to recent studies, when the oceans may have been covering the entire globe. Because of the angle of its axis, there are times when the temperatures at the equator is colder than at the poles, a situation which, if it occurred on Earth, would render the planet uninhabitable. According to other theories, the volcanic bulge occupied by Olympus Mons and its guardians contains cratering caused by meteorite bombardment, which are 2 billion years old, give or take 100 million years. Cratering across the Martian plains away from the volcanic bulge is believed to be about 3 billion years old. This would indicate the volcanoes emerged later, making them considerably younger than previously thought, and offering the possibility that rather than being extinct volcanoes, they are merely dormant, possibly to erupt again in the future. Another theory posits that rather than a series of eruptions followed by a period of cooling, a subsequent rebuildup of internal pressure and then another eruption did not occur at all. Instead, the theory supports a long, slow, continuous eruption, more of an oozing process over millions of years, as the source of the creation of the massive mountains. According to a 2017 study published in Nature Communications, a Martian volcano suffered an asteroid strike about 11 million years ago, causing debris in the form of meteorites to burst from the planet into the solar system. Some of these meteorites landed on Earth. Scientists called them nakalites. From careful study of the nakalites, scientists learned that the enormous volcanoes on Mars emerged at a pace which is more than 1,000 times slower than shield volcanoes on Earth. What does that mean? Simply that the slow nature of Martian volcanic activity created the slow growth of the volcano itself, and that it may not be finished yet. Another growth period could be forthcoming, proceeding at an almost imperceptible rate. The nakalites also reveal something regarding water on Mars. Flowing water leaves behind evidence of its existence as various minerals which form in rocks that water passes through. Such mineral evidence has been found in the nakalites born during the asteroid impact. From such evidence, some scientists infer water was flowing on Mars during the time the volcanoes, including Olympus Mons, were steadily spewing forth lava and growing to their current immensity. As the volcanoes grew and the planet tipped, the climate changed, and the additional heat caused evaporation. Without sufficient gravity or atmosphere to retain its water, Mars became the arid planet that exists today. Water exists on Mars today in the form of ice at the poles and submerged under the Martian surface. But most of the scientific community agrees the poles consist of about 85% CO2 and 15% water ice. Water ice being the scientific term for liquid water because many liquids can become frozen, thus becoming ice. The more you know, right? Olympus Mons and the other shield volcanoes on Mars are often described as roughly circular when viewed from above. A more accurate visualization may be that of the white of an egg frying in a pan. The yolk at the center is circular, the white surrounding it is irregular in shape. Such is the base of the Martian shield volcanoes. Surrounding the base of the massive Martian volcanoes are escarpments, steep cliffs that are easily detectable. The escarpment surrounding Olympus Mons varies in height when measured from the surrounding surface at the base of the cliff's face, which reaches about 7 kilometers, roughly 23,000 feet, along the northwest side. At its highest point, the escarpment reaches a height that exceeds that of Hawaii's Mauna Loa, an earthbound shield volcano. In the early 21st century, informed by then recent photographic evidence obtained by NASA's orbiters, it was postulated by several studies that the escarpment was formed by what one termed a catastrophic mass movement event. Expressed in more simple terms, scientists believe the escarpment to be the result of a landslide or several landslides. The studies determined that over the millions of years, continuing magma buildup on the slopes of the mountain gave way before, gravity did its thing, just as avalanches do when the weight of accumulated snow exceeds its ability to hold its position on the side of a mountain or glacier. Another study presented a dissenting view in the autumn of 2023. The study, by scientists at Paris-Saclay University, claimed the escarpment was once in essence a shoreline, formed when hot, flowing lava met liquid water. In their view, Olympus Mons, as well as the Tharsis Montes, were once islands standing in an ocean, which covered the Martian plains that now surround them. Their view essentially compares them to what was once a Martian version of the Hawaiian Islands or the Galapagos Archipelago, situated in equatorial Mars. The study cited similarities to numerous islands on Earth that bear strikingly similar characteristics to the Martian volcanoes, including, besides the Hawaiian Islands and the Galapagos chain, the Azores, the Canary Islands, and Cape Verde, to name a few. It also cited additional Martian volcanoes that bear the same characteristics. evidence to them that oceans once covered the red planet. But the study offered no explanation of why oceans cover it no more. And to be clear, there's no real reason why they would. The most accepted model for how this happened is that whenever Mars lost its magnetic field, the solar wind stripped the planet of its oceans and atmosphere. It can be inferred that if the height from the base of the escarpment to the northwest of Olympus Mons reaches 7 kilometers, then the oceans on Mars described in the French study had depths of at least the same distance, and extended over a considerable portion of the planet. That flies in the face of generally accepted science, which is that Mars once held some water, but not to the extent of Earth, where it covers nearly 3/4 of the globe. Other scientists disagree with the French findings, and the topic is debated with fervor, only to be found in academic disagreement over such arcana. Whether there ever existed extensive amounts of water, both frozen and liquid, on Mars, let alone its nature and extent, is far from a settled issue. Settling it with any degree of certainty will require more study and exploration of the planet than has been thus far accomplished. It remains an intriguing possibility, along with the question, if it once had water, where did it go and why? A mountain climber's dream exists on planet Mars. On Earth, the most challenging climbs are well known and documented. Mount Everest, for example, though some climbers rate K2 in the Himalayan mountains bordering Pakistan and China as the most challenging climb on the planet. Others claim Annapurna in Nepal offers the greatest achievement in scaling a mountain. The Swiss Matterhorn and Mont Blanc, both in the European Alps, are still climbs regarded with esteem by those who participate in the discipline. On Earth, the distance one must reach from the surface to what is deemed the edge of space is 100 kilometers or 62 miles. It is known as the Kármán line and is essentially the border between Earth's atmosphere and space. Those who reach that altitude are said to have entered what we call space. Thus far, it has only been reached by humans using aircraft or rockets. According to the Lowell Observatory in Flagstaff, Arizona, the atmosphere of Mars is so thin that the summit of Olympus Mons is actually above the atmosphere. The massive volcano protrudes through the atmosphere of the planet upon which it stands, which means should one be properly equipped and possess a soul with the necessary amount of daring, one could literally walk into space by ascending the slope, which, as noted, is a gently rising one, all the way to the top. Admittedly, it isn't going to happen anytime soon, but there is a challenge for all climbers to ponder. Some adventurous souls are already planning just such an expedition. Students at Sweden's Royal Institute of Technology in Stockholm proposed a pedestrian ascent, submitting their suggestion in 2021. It consists of a rover vehicle which would transport 3 climbers to the base of the mountain, after which the climbers would ascend first the escarpment, then the slopes of the mountain to reach the caldera on foot. Their suggestion mentioned a target date of 2042. Another group is already studying commercialization of Olympus Mons, proposing development of a virtual reality climb up the slopes of the mountain. To create such an illusion requires extensive mapping of the slopes and views one would experience on such a climb. Accurate mapping of the mountain is problematic to say the least. The use of a robotic rover would expedite such a task, but there are problems landing rovers on the slopes of the mountain. Landing on the slopes is imperative due to the daunting nature of the escarpment surrounding the mountain, though. Rovers are currently deposited on Mars by parachuting them through the thin Martian atmosphere, an already difficult task. As Olympus Mons ascends into the Martian sky, the atmosphere becomes thinner still, leaving little atmospheric resistance to be exploited by a parachute. Still, at least one company is planning to find a way to create an illusion of climbing the solar system's tallest mountain, and can be found by a quick internet search on the subject. According to the United States National Park Service, calderas are collapse features that form during large volume eruptions when the underlying magma chamber is partially emptied and the ground above it subsides into it. At the summit of Olympus Mons are 6 calderas, stacked one on top of the other. The size of the caldera stack is more than 85 kilometers or 53 miles across. The existence of 6 distinct calderas would seem to indicate 6 separate eruption events, when subterranean magma chambers emptied themselves of their contents and the mountain subsequently went to sleep, as it were. If that is so, then establishing the age of Olympus Mons is difficult. The original mountain, presumably considerably smaller than that which exists today, may be billions of years old. Other parts of the mountain, along the slopes and at the escarpment, may be considerably younger. perhaps only a few million years of age. In essence, each subsequent eruption created a newer version of the mountain, if in fact the eruptions were a series of events and not a continuous flow. Some scientists support the theory that the existence of 6 distinct calderas at the summit of Olympus Mons indicates the volcano may still be active, and that the future will bring a 7th caldera, and possibly more, though such a circumstance may be several million years away. Or it may occur at any time, either at Olympus Mons or any of the other known volcanoes on Mars, of which fewer than 20 have been named. There are those who believe the exploration of Mars, as well as the rest of the solar system and beyond, is a waste of time and money. I am not one of those people, if you couldn't tell already. Thankfully, the world's leading space agencies do not agree, and nearly all of them, including those of the United States, Europe, China, Brazil, Japan, and others, are actively studying the ways and means of exploring the Red Planet. Private enterprises are studying the possibilities, as well as with missions planned for as early as 2024. The prospect is challenging in the extreme due to the technologies involved, the distance encountered, and the hostile nature of the environment found there. Yet, it is ongoing. Exploring Olympus Mons and its 3 guardians, any of which would qualify as the tallest in the solar system were it not for the existence of the others, is a task for both present and future. Their summits are all above the Martian atmosphere, and the escarpments surround them as insurmountable walls, at least to existing technology. Yet efforts to explore Mars will undoubtedly continue. The planet holds a vice grip on the collective imagination of humanity, which has existed for just a minute fraction of the time that Mars has orbited the Sun. That grip shows no sign of relaxing despite the remonstrations of naysayers, and given the nature and history of the human race, likely never will. Someday, humans will reach the summit of Olympus Mons, and from that peak will no doubt find another mountain to climb. So I hope you enjoyed that video, and if you did, be sure to tell me if you'd like me to take a crack at writing a script about Valles Marineris, the largest canyon in the solar system. There's a fascinating theory that the canyon was formed when the cooling of Mars's core caused the crust of the red planet to crack like a hard-boiled egg, and I'd love to explore that topic in the future. Let me know in the comments down below. Wink. I'm Eric Malachite, and I'll see you next time, Space Cowboy.